So tonight I am coming to you from beautiful San Diego, and rather than break my streak of making videos on a daily basis and like going out and actually like having fun and doing stuff, I'm a workaholic. So I'm making a video here for some reason. And then here we are. And then today I want to focus on data vectorization for businesses very specifically. And I focus on this because as I've had more and more interactions with businesses on this topic and on these topics, this is the biggest topic that I found that has come up for businesses to understand, which is that you need to vectorize your data. What is the most important thing that you can do as a business if you want to get into AI? Vectorize your data, learn how to, and learn why to. Build the system around vectorizing your data, and then the model second. That's my approach, right? If you can get and build an internal system that is very good at getting your data into vectorized form, what model that you're using within that is secondary. The model can be swapped in and out, etc. If you have a very good process for that lined up. If you want any sort of like real-time updates, near real-time, etc., what a lot of businesses want out of these models, you need to learn about vectorization, why you should vectorize your data, and how to vectorize it. So I'm here for you to do that. And then so let's kind of break that down. In a simplistic terms, there's easy ways we can use like a scikit and a few other methods in order to vectorize data easily. But so let's say, and we'll simulate CRM data, right? And then so in this instance, I'm taking like customer ID, age, location, purchase amount, and then their feedback, like great service, product quality, could be better, satisfied, excellent, or very poor, like different types of feedback, right? And then so bottom line within this and pointing this out, this data is clean. Like if your data doesn't look as clean as this in any way, shape, or form, like if there's like anything that is deviant about your data, you need to fix it before you get to this stage. This is very clearly and very inherently like good data. If I did anything to like at all to make this bad data, that's the data that would come out. And then if I had like missing columns, some extra punctuation, perhaps like some extra, like if I had like extra parentheses, things like that, it would literally break it when I run it. So it's very important and imperative that your data is clean above all else. And then so if it's clean, as long as it's clean, and if you think it's clean, it's not clean, so do it again because it's not clean, but make sure it's clean, and then go through and then you just upload your data. It's very simple to get it into essentially vectorized form from there. So then I'm just creating a vectorization pipeline, right? So in this instance, I'm taking and I'm breaking it up into numerical features, categorical features, and text features. So I'm breaking it up differently than I would for like a traditional database, for example, right? I'm breaking it up into vectorization and what I need in order to best create vector categories as opposed to like say database tables. And then so the rest of this is just like processing for the vectorization, which is making sure that our data is clean overall within this entire process. And then again, it's just lots and lots of processing, right? And then I have the summary that we'll print out here at the end, and then we get our data. So this is our sample data set, right? And pretend like this is like your CRM or a table of data. And then, so again, here's the data, and then here's exactly how it's broken down. Again, notice that the data is clean, no missing columns, no zeros. Lots of things will throw this off, right? So it's very imperative, I'm just going to say it like 50 times, that your data is clean above all else. And then so if your data is clean above all else, what this translates into, so what we're looking at here is not what the model reads, cares about, etc. It literally translates it into a formula like this. And then so these are the numerical vectors, these are the categorical vectors, and then these are the text vectors. So we broke them up into 3 categories before, right? And then so now we're putting them into different tables. What we're creating is if you don't know, these are matrix arrays that we're creating, and then we're creating different matrix arrays based off of the different types of data, right? The different data sets should go into different matrix categories. And then so that's essentially what we're doing and filling out and separating within this data. But so this essential part, like making sure that your pipeline is good and can handle this, as I'm going through this, hopefully you can see and understand how this actually becomes a bottleneck for a lot of businesses. And it's actually hard, right? It's easy to say, just throw your CRM data in there and like hook it up, like give me the API and it'll do it. But then once you get into there, then it's not actually like not good data, and then you don't actually have a process to handle it and to categorize it and to break it up into these individual categories and then to handle it once it's in these forms from here, right? But then so that's what you like, again, what is most important for businesses to work out, and then the least important thing for the businesses to work out in this equation is like what model should be doing this. So I'm going to show you in the end, like I'm just going to process this data via a model that I build, like flat out, and it's simple, right? Because what we're looking at here isn't something that needs to be like just thrown into an LLM model and have the LLM model handle it. Like, could you do that? Like, sure. Like, can you do that? Like, would you? Like, should you do that? Is the question, right? And like, as I've stated a lot of times on this channel, like you can run Doom on potatoes. It doesn't mean that you should run Doom on potatoes, but you can do that. And then so in this instance, you can just upload all of this to an LLM model, and then you can upload it unvectorized and then say, hey, go to town on it. But should you do that? It's the equivalent of running Doom on potatoes. Like if you do that and I do this, I'm going to smack you around as far as like performance and accuracy. And then when you're actually dealing with like real world dollars, and then if we're competing against each other, like that escalates, right? Like eventually, like I'm going to put you out of business. It's the bottom line of how that operates. It's like less efficient overall. Your method isn't as good for a lot of reasons overall. It's less like more computationally expensive. So it's more like far more expensive for you to run your system than it is for me to run this system. Because again, it's just, like this is all Python code that operates and runs in seconds, right? As opposed to your LLM model, and this is all running in free Google Colab, no CPU, no GPU required. And as opposed to like any LLM model, pick one, right? That would be doing these same type of tasks. And then again, the accuracy will be better if I tune this model out and train it out, which I'll show you in this instance. I don't fully tune it out and train it out, but it would be easy to in this instance. So what we do is I create this, and then so I get their final vectorized data set. So rather than our table here, like this is the human version of the data set, this is the AI version of the data set, right? And then so this is what it gets and then what it cares about at the end of the day. So you can see this is a very different chart than this chart, right? Very, very different. Here's one is not like the other. So if you can build a system that does this, again, this is like the best thing that you could possibly do for your business. What can I do for my business that's tangible? Here, do this. If you want to get into AI, do this above anything else before you do anything else for your business with AI, and you'll thank me a million times over later. And then like this just gives you like, so like what this does is it gives you like the actual visualization of this. And then as you can see, it breaks down into very nice geometric representations, which is why I talk a lot about these things within geometric terms, right? But then so what I just showed you is running the model, but what you want to see is taking the same exact data. So I'm just taking like everything that I did before, but I'm encoding it and decoding it. So meaning that I'm actually running it through a model, right? So then what I'm doing in this instance is that I have essentially all of the same data. So say this is our CRM data, and then I have a target variable, which is either above average purchase or below average purchase based off of their purchase amount, right? And then so I want to then start taking this data and categorizing it. I want to start training this model to like increase our sales, for example, right? And then I need to train it on several different metrics from here. So then I take this data and then I want to, from here, like break it up into several different components, right? But I need it in all vectorized form in order to do that. So then if it's in vectorized form, I can just take it and split it out all of these different ways, train it and code it exactly as we're seeing here, right? So in this instance, I just take those vectors that I created before and then I run them through the model. And then in this model, model, it's getting between 75 to 100% accuracy. There's one test here on this recall where it gets 50% accuracy, but then you get to the rest. These are between 85 to 78% accuracy, 100% accuracy, 67%. Like on this above average, it seems to do poor overall, although it is also the one where it gets 100% accuracy, right? So kind of weird how that functions out. But again, I could easily train this model further, adapt this model, like make these numbers and skew them up to 100%, which is something that I couldn't promise you with an LLM model, right? You'd be throwing more compute at the problem, and I couldn't tell you that it would be 100% accuracy. I couldn't tell you that I could trust the output of the model, that I could verify it, that I could trace it back on any level. Within this, I can trace all of this back, right? I know exactly what it's doing in this instance, what it's measuring off of, and it's a lot more traceable than just giving it to an LLM model, right? As far as this data, and then here's like what it predicted. Here's its predictions overall. I can easily put this into charts, diagrams, whatever you want from here, right? But so overall, bottom line, if you can do one thing for your business overall, what should any business focus on? It's data vectorization. Like I can't stress that enough to any business out there on the planet. Like before you're thinking of models, before you're thinking of anything else, think about your data vectorization strategy. And if you don't have one, then you should start there. If you like this type of content, please like to subscribe. Thank you very much.